Okay, welcome to another devlog. Um, this one's gonna be simple. Um, yeah. So I decided to build a really funny program called Battery Warning. And the reason I built this was because I don't have any notifications in my computer, and so when I'm out and about and I'm not plugged in, my laptop will turn off without telling me, even though I have a little percent thing here that I do not pay attention to at all. So I'll be in the middle of work and it just shuts down, which is really funny. So what I decided to do is I wanted to understand how to do sound on. I wanted to understand how to emit sound on Linux. So I found a really good OpenAL tutorial, and there doesn't seem to be a lot of libraries where it's just play the sound, like kind of like how you have in the browser, or in Flash, or even on iOS and stuff like that. So you kind of have to do it all yourself, which is kind of fun, but thankfully it's not as hard as you think. You can see I've created a custom structure here, and then I got my own function. So we'll go over that. The other thing that is in here is I'll briefly go over is just how to read the Linux power information using sysfs, or system file system, I guess. And yeah, so to just dive into it, I don't think I'm going to demo it because it's kind of annoying. But basically, it's a very simple C program. But what I did is to kind of like demo it without demoing it, is I just configured my sway config at the bottom here to execute battery warning. And so this program runs in a loop, and every second it'll check, hey, what is the percentage? And then if it is lower than the target, which you can see here, the target is 5, then it's going to play this wave file. This was just kind of hacky. I just created a sound on my Mog, which was fun. And then that's kind of it. I'm not going to play the sound because it's kind of alarming. But here you can see, to dive into things, the biggest things actually, no, I just go over it. I just have this main function. I check if the wave file and the target have been declared. I probably got some really bad error handling going on, but that's it. This first chunk here, this kind of inits the OpenAL sound system. And I've created a very basic structure, which you'll see in a second. It just sets up the listener and assigns the sound to the file that you specified. Then what we do is we simply have this loop here. So this is the loop that I was talking about a few moments ago. So it will sleep for 1 second. Then it's going to check, hey, is the AC on? Yes? Okay, just sleep again. Then we check, hey, is the battery percentage greater than the target? Is it? It's 100 right now? Okay, yep, continue. And then it sleeps for another second, right? If it goes past those 2 checks, then what we do, here's kind of like the core sound code, is you have OpenAL source play. And so we're going to play the source, and then we're going to get the state of that source, right? And store that into a variable, and then we're just going to loop while it's playing, right? Because we don't want to keep checking while it's playing. If you're in like a game or maybe some other situation, you want to play something and then continue going, I think you might have to throw this in a thread, or find another way to do it, or you just there's lots of ways I guess you could solve it. But anyways, that's where we have the next while loop. So we just say, hey, while it's playing, we're just gonna hold on to our horses, and then once it's done playing, then we sleep for 4 seconds. So the idea is like, hey, oh, all of a sudden the battery is less than 5%. Okay, I'm gonna play it once, then I'm gonna wait 4 seconds. I'm gonna wait 1 second, so that's a total of 5 seconds, and then redo the check. And if I'm still not plugged in, I want to make the sound again because my owner has not taken action. That's kind of the user experience behind it. Just keep making sounds until I'm plugged in, otherwise I will die. Then once that happens, I have this sound free. Obviously, we never get there because you'll either turn the computer off or you will terminate the application. I could handle the the sig term kill or whatever to do that more gracefully, but this was just here when I didn't have a loop, and I just left it in because it's probably nice to have. So to jump into the sound system, how that works, there's a tutorial. I'll add it to the description of the video, and it's very simple. So here, what I decided to do is have a sound structure. This is a really bad name, but basically it contains the device that you're going to use for sound output, the context, then the source and the buffer data. I would assume to further build on this, you'd actually take these 3 lines and the source, the buffer, and the buffer data, and that would become a sound itself, or a prepared buffer that you can play at any moment. And then you'd load each individual wave into that own structure, and then you'd tell the sound manager, if that's what we're going to call it, to play that specific sound. Here there's a helper function that's from the tutorial. PanicAL is just like, hey, if something bad happens, just kill the program, which you probably don't want happening for this program, to be honest. You probably wanted to handle gracefully and just continue going, but right now this hack project is just doing that. Then you have I've created a init function, so to init the system, then I have assigning the sound source, so give it a file name and assign it to the source, and then you have your free function, and then you have your listener, set listener transform, which is something that I'll get into. So sound init, very simple, create the structure, and then we're going to open a device, and we're going to create a context. If any of these things fail, it will panic. This is actually wrong. I should return null if that happens, to be safe. Here's where you assign the sound. So, oh wait, 1 sec. Yeah. Here's the sound assigning. So when you assign a wave file, you have to set the source, pitch, gain, position, because it is 3D audio. It's not just like a 2D thing, but I've kind of basically done 2D here by centering it at the origin of the world, it looks like. So you can set looping and that kind of thing. So then you generate the buffers, and then you actually have to use the library. Let's see here. Yeah, you have to use the audio wave library to then read it and seek it, get the buffer data, and then read the wave file. And then finally, once you've read the wave file, then you can put it into the OpenAL buffer data, which then, right here, assign it to the source. So a lot of work under the hood in playing a simple wave file that you would never really realize if you just did it in the browser, because I think in the browser you just go new audio, set the source, and then hit play and it does it, and it does all this behind the scenes for you, so that's pretty nice. But obviously if you just make a good C library, you can make it as good as that. There's just a lot more to do, because nobody seems to create these libraries and share them. I mean, yeah, mine's far from shareable, so maybe that's why people don't share their libraries. They all just make very specific ones, and I wouldn't be surprised actually, because it's so low level. This is the free function. You're just cleaning things up. Not a lot to go over there. Here's the set listener transform. So this is interesting. I think it's because there's only one listener of the audio. So basically it's like this global that you are assigning the position. So you can set the source in 3D space, but you also set the listener in 3D space. So you can say like in the world I am at the center, and then our source also have me be at the center. And I think OpenAL will handle the rest. So if you like move it to the right, you move yourself to the right, or you move the source to the right, it would have that effect there. And it would come out of the right speaker or the left speaker, or it would do the projection mapping between the left and right to make it sound like it's in front or behind you if you have headphones on. That will work. So kind of cool effects that you can make with 3D audio with only left and right channels. This is a helper function, just getting the format. Yeah, I only handle 16-bit audio here because that's what the tutorial had, but you'd obviously want to handle 24-bit since that's pretty popular. Although I guess samples, not bits, right? Yeah. Then this is the back function, dumb thing. So that's kind of it. Yeah, there's that set listener sound that I forgot to go over there. You init it, then you set the listener. I'm sure you can do that beforehand. That's kind of it. That's part of the audio. So this is a lot of work goes into getting audio to work, and that was fun to figure out. The other thing is the power. So the power is using system file system, I guess, sysfs on Linux, and there's it makes it really easy for you to get or query about the system. I kind of wish you could do Bluetooth and Wi-Fi like this. I haven't figured that out. Maybe you can, because I'd like to be able to get the same information for like Bluetooth here, the Wi-Fi, that kind of thing. So in order to get if the AC is online, all you really have to do is you have to check these files here, and if the file is like a 1 or a 0, or if it doesn't exist, then it's obviously offline. But as you see in the comment here, you don't actually want to just query these two files. What you should do is you should iterate through the directory and check if each file here, the type is of mains, and then you want to see if the online status is there. And that's kind of what this battery filter does. What this battery filter code does is this is for the directory entry function. So you can pass in a function that evaluates a directory entry, and it just checks is the current file here of type battery, and if it does, then it returns true. Otherwise, it returns false. And then that's used in this batteries list function, which just returns a list of file names that are batteries. So I scan the power directory. Are they batteries using the bat filter? And then it returns, it fills this array of directory entries, and then for each one, I simply just concat the string and assign that to the list. Getting capacity and getting the battery status is very simple. You just query the file for the capacity file or the file's capacity and status based on the file name. So for like bat1, it'd just be sysfs class power supply bat1 /capacity or status, and then, you know, capacities is simple A to I, and then the status is I created a numerator, and then I just do string compare, and I return the value based on that. So super simple, fun hack project. Oh, and there's also same thing here for getting the name of the battery. This is helpful if you want to know if like it's for your mouse or if it's the laptop. So like usually on the laptop or framework it says like framework or just whoa. I guess to keep it short. But yeah, and then there's just some helper methods down here that are kind of private. So it just makes it easier to do the same repetitive functions for like reading files and stuff like that, or cleaning up some things like extra new lines that you don't want. So that's basically it. Very fun hack project, I must say. I will probably continue to use it as I build out more operating system tools. Yeah, get less clunky, more refined. But that's it for this devlog, and hopefully more for YoSup and other things that I'm doing. So yeah, peace out and see you next time.